FlexSTONE flexible cement systems for long-term cement integrity for all of your zonal isolation challenges. Poor cement compromises zonal isolation in a number of different ways. These include incomplete cement coverage from poorly placed cement, a cracked cement sheath because of high wellbore stress levels, and a microannulus because of a pressure drawdown, which could lead to a well security incident. Conventional cement systems can fail under pressure and temperature cycles. The cement cracks and fades. The cement can shrink and debond to compound the effect of loss of zonal isolation. Now we'll see how conventional cement performs when subjected to increasing temperature. In this test, a 1-inch diameter steel pipe is surrounded by a sheath of cement in an unconfined environment. This is the worst-case scenario. On the right, a temperature of 64 degrees Celsius is reached as hot water is poured into the center of the tube. The millistrain gauge appearing on the left indicates the strain generated by the metal pipe, which is expanding because of the hot water inside. This expansion is transmitted to the cement sheath, which sees a rise in annular stress to accommodate the increased diameter of the metal pipe, just like the effect of a pressure test in a real-world situation. The strain level continues to increase as the metal pipe expands. The conventional cement shows failure in tension and a longitudinal crack appears along the entire length of the cement sheath. At 0.6 millistrain, the failure is complete. The cement sheath has failed in tension and zonal isolation in an actual well would have been compromised. Clearly, the conventional cement system is not flexible enough to accommodate the changes in tensile stress exerted by the metal tube. This is a classic case with non-flexible cement systems. In this scenario, the Young's modulus is too high. This cement system should not be used. To handle these stresses, you need an engineered flexible cement system, such as our FlexSTONE cement system. Based on our field-proven Semcrete technology, the FlexSTONE system allows expansion to levels not possible with conventional cement to seal microannuli. The system is engineered with a level of flexibility to manage change in wellbore stresses. The FlexSTONE system can be mixed across a density range from 10 ppg to 21 ppg in many different wellbore scenarios. The key to the FlexSTONE system is the trimodal design that utilizes 3 different particles. The system expands to seal microannuli, maintains cement integrity under changing stresses, and can be mixed from 10 to 21 ppg. The particles are arranged to pack very efficiently, with coarse, medium, and fine particles creating a closely packed matrix that requires less water, yet produces production-quality set cement systems every time. As with the conventional cement test, this small-scale test involves a short length of steel pipe, 1 inch in diameter, surrounded by a sheath of cement in an unconfined environment. This can be regarded as the worst-case scenario. To the right of the screen is a temperature display of 81 degrees Celsius as hot water is poured into the center of the tube. This is hotter than the conventional cement test. The same millistrain gauge is to the left. Remember, the conventional cement failed in tension at the 0.6 millistrain line, as shown on the gauge. The strain increases to the 0.6 millistrain mark and shows no sign of failing as it passes beyond the conventional cement failure point. The strain level reaches a maximum of 0.8 millistrain, and the level of expansion in the metal pipe is at its highest, but still the FlexSTONE cement sheath shows no indications of failure or cracking. At 0.8 millistrain, the FlexSTONE sheath remains intact and hydraulic isolation has been maintained. FlexSTONE systems withstand 30% more deformation than conventional cement systems. They tolerate high casing pressure and temperature changes and are engineered to be as flexible as required for a given well scenario. If you produce these test conditions in a well, the conventional cement would have failed in tension at 6,000 psi, whereas the FlexSTONE system would still be intact at 8,000 psi. So if you have a dynamic stress environment in your wellbore, a FlexSTONE system can be engineered to maintain cement sheath integrity and be applied to wellbore stresses created during the drilling, completion, production, stimulation, and abandonment phases of the well. FlexSTONE technology increases the production life of the well, seals microannuli, isolates stimulation zones, and improves casing protection. To learn more about how the FlexSTONE system ensures long-term cement sheath integrity for all of your zonal isolation challenges, visit our website at www.slb.com.